Welcome to this topic area. It's called type certification. It's kind of maybe a wrong title. It's really type certification of things that don't fit in the category that Brent will describe in the next session. This topic area is for certification of turbine systems to IEC 61400-1. And so this covers the turbines that don't fit under the size limitations of IEC 61400-2, which is limited to rotor swept areas of 200 square meters, which back when that limit was set covered turbines into about 80 kilowatts. These days, with larger and larger rotors on there, that limit might be hit at lower rated power limits. And so if you exceed the -2, but you still would like an international certification, then this would be the category for you. You can exceed 200 square meters and still fit in the topic area that Brent will describe by fitting under the ACP standard, which then has the peak power of 150 kilowatts. And so there is an area where you could qualify for either this area or the previous area, and you have to kind of decide which one fits best with your market and your business plan. And then, as we said, the upper limit we've traditionally had was 1,000 square meters, and if that doesn't work, if there are products out there that are bumping up to that limit that you think we should consider, that kind of feedback would be most welcome to us, and we can see if we can incorporate that. The end result here is to have a fully certified production turbine available to the US market. A very simple outcome, but a lot of activities that go in there. All turbine configurations are eligible. Depending on your configuration, that path may be more well-defined and simpler than for others. Traditional horizontal axis wind turbines have a much smoother path because things are much more readily defined. Vertical axis turbines, there's a lot of white space there that will have to be defined with your certification bodies. And then, of course, if you have even more complicated concepts, there will be a lot of back and forth with your certification body while you go through this process. Last, certification should be done by an accredited certification body. And so if you're talking to a certification body, make sure that they have IEC 61400-1 in their scope, and they should be able to show you that. Otherwise, there are lists of certification bodies out there under IECRE, for instance, or otherwise talk to us and we can kind of confirm that that's the case. In here, listing of electrical components, and as Rob Wills and Brent showed earlier this week, right, that becomes more and more a requirement for certified turbines as well. That's also something that we can cover here. So the scope of work and the chart on the right-hand side comes out of the IEC, IECRE, so the international certification scheme. But the building blocks there are fairly generic. And even if a certification body is not doing this per the IEC process, they would still have all these kind of key blocks in place. So you usually start with a design basis and evaluation, work to the design evaluation, and I think I'll touch on some of those a little later on here, what those are. But you would work your way through these things. The best description of what I think the type certification process looks like can be found in IECRE OD 501, and the link is given there. It will describe all the modules. It will describe kind of what you do in the modules. It says expectations of the kinds of documents that exchange hands and what people do. And then, as previously described, UL or a listing to UL standards. It doesn't have to be by UL, but somebody that's a NREL that's allowed to assess or issue the listing to UL standards is also included in that. And then, yeah, just listing by itself is not the effort here. There you go. So the disclaimer there, the combination of type certification and listing cannot be the only effort. And also, if you don't do listing, there should definitely be a plan for that. Because in the end, we want to make sure that there's a fully certified turbine system on the market. The design basis evaluation, so that was that first building block we saw at the top. That's really to kind of define what we're going to do. So what are we certifying, and what are the standards we're going to use? What are some of the design assumptions? So what wind turbine class are you going to certify to? How are you going to do that? So I see this really as a certification plan to some extent. What are some of the materials you use, for load factors you're going to assume? In this case, since we are in the large turbine category, simplified load models are not acceptable here. So it will have to be an aeroelastic simulation. And but in general, this one is really to kind of say, okay, what are we going to do? So the next one, the design evaluation, will then start. And so here you'll have your certifying body basically do an independent review. And so there's two ways to look at certification. Some see it as a necessary evil barrier you have to get past to get into the market. Others will more see it as a great opportunity to have very experienced engineers independently review your design and ask you questions. So I'm more in the second category, where I think the value is to really have somebody else scrutinize your design, scrutinize your design assumptions, and give you really good feedback, and kind of have that loop closed. In my personal opinion, it's critical to assure that that control protection system meets all the requirements, and do that early on. If you start going with loads and then start doing basically strength analysis of your components, and then you find out that your control protection system is not in compliance, that will then in turn affect your loads again. So your control protection system will basically drive what your load cases look like, and also what your faulted load cases look like. You have to assume a single fault in your control protection system, and that really is tailored towards your specific design. So we really want to make sure you do that early on before you get too far into the strength evaluations. The other word of caution there is do not underestimate the level of effort it takes to develop the materials that you have to prepare for your certification bodies, right? So you're going to have to present what you did and why you think it's all okay on paper to a certification body, and they have to be able to read through it. And that takes a lot of effort. So keep that in mind when you're thinking through this process. We see a lot of effort going there. The next block on that chart is then type testing. And type testing under IEC has 4 components. First one, safety and function. And we've heard earlier in the week what that entails. Power performance, load measurements. Note that for an IEC 614-1 certification, loads measurements for the purpose of model validation are a required part of the certification. And then for blade testing, both static and fatigue testing are required blocks. And so that's also why the cost is quite a bit higher in this topic area, and thus also you'll see that the available funding is higher. Note that acoustics is not part of type testing. It's part of the optional type characteristics testing. You can include it in here if that's important to you, and I think we would all agree that to get into the market, that's something that you definitely would like, but it's not a required block for certification. And then another kind of note there, make sure that the test site and the test plans are accepted by the CBE. So and do that before the testing starts, because otherwise you end up with test results, and if those don't get accepted by your certification body, we've done a lot of work for nothing. So we expect that throughout this whole process, you will be working along with your certification body on a regular basis. So the tasks basically follow the chart on the right. Design evaluation, just the turbine commissioning. So we assume that the testing will be happening here. It could also be that you already have testing that is acceptable by your certification body. That would be great, because that will save an awful lot of work. But there's risk there to make sure, right, that the testing you've done previously is accepted by your certification body. manufacturing evaluation. So this is where the certification body will make sure that the processes you plan to use for the manufacturing of your turbine will meet all the design requirements to meet the design, or to get to the design that you've certified. Type testing, as we described, and then task 5, post-test review meeting, and then last one, of course, is the final evaluation type certificate. We have inserted 2 go no goes in this area in the past. One is right after that design basis evaluation. So we really have a really good clear picture of what you're going to intend to do. To me, I see this as the certification plan that really kind of lays down what are we going to be doing here in this project. And then the next one is after the design evaluation. And the purpose there is to kind of say, if the certification body says, yeah, this turbine does not meet the requirements of the standard, then there's really no value in moving forward with the testing. So we want to make sure that the turbine is certifiable before we do the testing. A lot of deliverables here, but logically, these all fall out of these building blocks. So after each of these blocks is completed, a certification body can issue a conformity statement saying that you've successfully completed that building block. So that's what you're kind of seeing here. And then, as others have said, quarterly reports on top of that kind of on a 3-month basis kind of allow us to kind of track your progress and see what's been going on. Scoring criteria, there's 4 here as well. 3 of those are very similar to other categories. So the first 2 are really about tell us what your turbine is, what its cost of energy is, what is its configuration, why does it matter in the market, right? What is the market? What is the application? How big do you think the market is? And how can you support it? And of course, the last one there is another easy one you've seen. Like, okay, can you show us that you've got a team that can handle all the activities that you need to do here in the type certification? So that might include external loads consultants or external structural analysis consultants. We'd like to know who your certification body is, et cetera, et cetera. The number 3 there is the one that's unique here. And so here we want to see that your turbine is really ready for type certification. So it's not in the early stage. We'd like to make sure you've got some track record, and the more you can show us, the better you can build your case that you can handle this quite expensive thing. Any kind of prototype testing that you've done, of course, your ability to deliver a turbine or deliver components for NREL listing. We want to make sure that you're ready to do that, because otherwise, if that takes a lot of time, the certification process takes a lot of time, the testing takes a lot of time, this project would take a lot of time. To that end, also number 4 there, we want to make sure that the test site, the test facility you've selected can complete the testing within reasonable time. So if you're trying to certify a turbine to class 1, very high wind conditions, but you select a test site that's more in line with class 4, it would take either a tremendous long time, or you'd end up with a lot of exceptions on your certificate, which is really not what we're going for. Then we'd like you to have started a conversation with the certification body. So we would like to, at this point in time, know who you're going to kind of go certify with, and you've had some initial conversations. So that's something we'd like to see. And then the last one is really the next one there is a certification plan. So how much money are you setting aside? Are you setting enough aside internally and externally, right? The certification body will cost funding, but also, as I said, internally you need to set enough funding aside to develop all the documentation, do all the analysis. And then there is something, and all of this is based on our experiences over the year. Unfortunately, we want to make sure you actually have these standards and you've opened them up and have some decent understanding of what's in them. And the more you can convey that, the better your case is built. Last, we'd like to see a preliminary loads report. And this is really also to kind of better understand the turbine and understand that you have some basic capabilities on your team that helps us assess that this turbine can be certified. Funding, so it's quite a bit, up to $800,000. Price participation 20%. Certifying, I mean, certifying to -1 is really similar to certifying a large turbine. So the cost for large turbine certification are quite high. Quite a bit of testing in here as well, and so that's why this amount is set to 800,000. 3 examples. We typically don't have a lot of turbines in this category. So I've listed 3 here. We had the Endurance X35 in this, 225 kilowatts. That project was terminated due to bankruptcy. The Northwind 100, they went through a type approval for German approval. So the DIBT, I think, is the German building code. So they did that one, and they used -22, which used to describe everything that OD 501 currently describes. So -22 has since been withdrawn and it's been replaced by OD 501. And so they did -1 certification pretty much in line with what I've just shown you with those same building blocks. And then we had a successful application from Star Wind, but they were just outside of -1 and the old SWT -1, but now they fit under ACP 101-1, and so they've pivoted to that certification and no longer -1. And that's all I had for today. So if there's any questions.